Let's discuss today tracking in some special cases. For example, in narrow aisles. So this photo we received today from the customer, and customer asks us how to track in such a pretty complex area. And yes, the answer is not simple at all, because what is the problem? The problem is that this is very narrow and this is very long. So it means that if you typically install one station beacon here and another there, the ratio of the width to the length will be too small. So it means that the width is too small as compared to the length. So effectively, and if you combine it with the height, it makes the trilateration even more problematic. And as a result, instead of 2D tracking, you have 1D tracking. Yeah, you can try to do 2D. It will be kind of, and you can see the video. So watch this video. It will be kind of working, but the closer you come to the line connecting the station beacons, the worse it will look. So you will still have very accurate X tracking if X is this axis, and the more you come to this area, the worse will be Y tracking. Okay, we can try to jump to
Let's
some.
now discuss the opposite scenario.
Okay,
X is
so this is their situation. You will see that um, X coordinate will still have plus minus 2 centimeter, but this will be having, I don't know, plus minus 10 centimeters. And the closer you come to the line, it will be plus minus 15, plus minus 20 centimeters. At some point of time, you cannot talk about 2D tracking anymore. And that was pure 2D tracking. In this case, there will be also height difference, which will introduce additionally narrowing of the angles, and the trilateration will be poor. Okay, but the situation is very typical. What to do in this case? Well, one of the solutions is that you just track above the shelves. So, for example, you have a robot, and the robot, scanning robot, the robot drives between the shelves. It scans the QR codes. It kind of estimates what products there and populates some database or CRM or warehouse management system. Um, So what you do, you have a robot, and then you have you install on the robot a small pole, which will be above the shelves, like in this case. So you install the station beacons on the ceiling, on the walls. It basically doesn't matter because, for example, this doesn't look like a huge warehouse, and but very densely packed. So it meant that your robot must be above the shelves, not the robot itself, but at least the microphones, the uh, the Omni microphones. You install them. They have very uh, easy to use 1 meter cable. So it means that your robot can be 1 meter below the microphone. The microphone will be above the top shelf, and the microphone will see the station beacons which I installed there. So in this way, you avoid all kind of issues. It's a basic 2D tracking, and you can see their placement manual, check the 2D tracking recommendations. So this is your case. So you install the station beacon there, but instead of small whatever robot, you have a robot with, for example, this is the height of your shelves. So your robot, which is, I don't know, 1 meter tall or 1.5 meter tall robot, and then you additionally install the pole, and the pole is above the shelf. For example, this is the height of the shelf, so the pole is above the shelf, and you have a 2D tracking in this area. Easy. So you avoid. Since you sometimes, or not sometimes, but quite often, you need not only the location but direction. So you install two mobile beacons with the base of starting from 25, 30 centimeters. If you have larger, like half a meter, for example, you will have a very accurate not only location but also direction. So that's the very typical case. So first solution is, and the easiest and the recommended, if you can do that, track above the shelves, and there will be no problem at all. It will be a very basic 2D tracking. If you cannot do that for whatever reason, for example, you track a person or you track a tool in a person's hand, then use 1D tracking in ALs. Let's look at the map in more details. So this is the shelf, this is shelf, this is shelf, this is shelf. And this is AL, very narrow AL, for example, I don't know, half a meter or 1 meter AL, very narrow. And this is, for example, 10 meters long. So what you do, you install one station beacon here, one stationary, one stationary, one stationary, and each of these station beacons, they cover this area. They cannot cover through shelves because there will be no line of sight, and line of sight is a must. So it means that you create multiple small submaps with a single station beacon, 04, beacon 05, beacon 06, etc. And each of these beacon serves its own service zone. So this is service zone, this is service zone, this is service zone, etc. These two station beacons are taken in 2D, and you can see they can cover a huge area, for example, 25 by 25 meters. So the maximum distance would be less than 30 meters recommended. Some cases could be more, but we don't recommend overstretch the capabilities. But this area, this what we are discussing, very narrow, multiple small submaps. Of course, there will be handover zones. So it means that when you move, for example, there is a door, you come here, you are in 2D tracking, 2D, 2D, 2D. Then you go to the handover zone 05A. So this is a handover zone between submap 01 and the submap 04. Then you go, and then you move to this handover zone, which is a handover zone between submap 02A and 04. And you are still in 2D here, and then you jump, hopefully not jump, but soft handover to 02A service zone. Of course, even in 2D, you need the height of the mobile beacon. So, and you move. And when you move to 1D, the 1D tracking assumes that the height remains the same. So it's a big assumption, not too terrible assumption, but still, for example, you have people of different heights, or people are moving arms with the tool up and down. So yes, you will have some inaccuracy when your height will differ from the height that you enter, but it will be not too much different. So it meant that you move, you move from 2D to 1D, then you come to this area, then you return, etc., and you do switch between 1D tracking to 2D tracking. So that would be the recommendation, because it helps you saving on the number of beacons. You don't install 2 beacons instead of 1 in this area. And second, even if you install 2 beacons, you still have effectively 1D tracking in this area, because the width or the length is very long, and at the same time the AL is very, very narrow. So there's no point to install the station beacons, and you save 50% in this area. This area is typical 2D, this area is typical 2D, this area is typical 2D. You can do 3D as well, but if you have only 2D tracking, there's no need to create 3D submaps. Again, you need more beacons. The accuracy of 2D will be still higher than in 3D, and you don't benefit. What to pay attention to? Well, with this 1D, it's clear. So you just have multiple submaps for each of the AL. But some areas, for example, will be tracked less perfectly than some other areas. For example, this is the problematic area. This is the problematic area. This is the problematic area. This is the problematic area, and this, for example, a problematic area. And this and this. Okay, why this is a problematic area? Well, for the same reason. Look, so this is the beacon and this is the beacon. If you're in this area, in order to track, you effectively have 0 or whatever 2 degrees angle. So your triangle is almost 1D. So it's not a triangle anymore, it's a line. So it means that the tracking in this area will be poor. So what are the problematic areas? So this area is problematic for the same reason as this one, because these beacons cannot serve them well because it's a very narrow angle, and these beacons cannot serve well because it's very narrow angle to them. So yeah, they will be tracking, but you can expect good tracking quality or accuracy in this direction and poor in this direction. So it's possible. It would be possible for some very complex systems to combine this information with this information to take X from this, which will be Y in this area, to take Y from this, which would be X in this area. But it's overly complicated. Just remember that in this area, the tracking may be not perfect at all. In this area, the tracking will be not perfect because of ultra wide base. You see, it's too close. So it means that you will once again have a very good tracking in this direction and very poor quality tracking in this direction. So effectively, it will be for the same reason as here. You will have a 1D tracking in this area. So it means that we do not recommend to come too close to this. Typically, it's not an issue in practice because you cannot come whatever 20 centimeters from the shelf. You always keep whatever half a meter, and the tracking is already reasonable and that. But it's always not about the matter of distance, but about the ratio between these. So it means that if you want to come too close, or let's say very close, then the distance must be reduced, not because of maximum distance limitation, but because of this ratio, this distance versus this distance limitation. Another area of problematic, this one. For example, like in this, if you have a distance from this beacon more than 30 meters, we do not recommend to have it more than 30 meters. There is no clear cut. And if you have whatever 32 meters, it's okay. But don't overstretch, because the larger the distance, the higher chances of noise, the high chances of missing the tracking in this area. So just remember about this. As you can see, this picture or this map and this map slightly different. So what's the difference? The difference is that when you have not only very narrow but very long ALs as well. What does mean long? It means that the distances here are already more than 25 or 30 meters. So it means that one beacon cannot cover the whole length of the AL. Sometimes the ALs could be, I don't know, 50 meters. So, and that may be not enough. So what do you do? Well, the simplest solution, you install one beacon here as always or as before, and another beacons here, maybe around 25 meters. And the length of the submap would be 30 meters, with this area to be a handover zone between submap 02A and 10A. And this is the handover zone between them. So this beacon starts effectively showing from this area. Oh, actually, I need to correct myself. So this beacon must be here. So it cannot see behind it. So the beacon must be here, like 04. So black point must be around underneath this. It means that it will start serving here, and it will continue to this area. So this is just a variant of the same. No fundamental difference. All other areas are the same, but simply when you have a larger or longer ALs, you will need also more beacons within the AL to cover. What are these beacons? These beacons these beacons can be regular super beacons or industrial super beacons. We typically recommend to install them on magnetic holders, so it means that you can point to the right direction. Okay, it's here easy, but for example here the beacon must not point to like this. It must point to the center. So it's better to use the magnetic holder. But then again, when it refers to the center, then you may create additional issues in this area. For example, when you point to the center, then this beacon or this area may be even less covered. So there is a trade-off, but it's not a subject for this discussion because we are discussing how to cover these particular cases with narrow ALs. Some other things to remember, potential problems. So line of sight. Line of sight revolves or defines everything, and everything revolves around line of sight. The problem is that if you install beacon like this, for example, here and here, these beacons cannot penetrate through the shells because of multiple obstacles. On the one hand, on the other hand, in some cases when the shelves are empty, it can penetrate and thus interfere with the tracking system in their neighboring ALs. So it means that it's important to choose the frequencies wisely. And how to choose the frequencies, there's an article about the submaps, how to build submaps, what submaps are, and read those articles. Okay, my internet connection stops working anyway, so you can find them. You can find there here basics about submaps, how to build submaps. So check them; it's important. And if you have very many small ALs, then you can quickly run out of ultrasound frequencies because there are only 8 ultrasound frequencies. 19, 22, 25, 28, 31, 34, and 45 kilohertz in our system. In large warehouse, it's not a problem because you have larger distances. You have larger submaps, and the next time when you need to reuse the frequency, it's far enough, 40 meters, 50, 100 meters. So that's not a problem. But when you have such a densely packed area, it is a problem because their next frequency may be just whatever 20 meters away, and with 20 meters it can propagate through the empty shells, for example, and then interfere. So you may need to use time division multiple access, but time division multiple access between, so it means that you don't have the same submap using the same ultrasound frequency in inverse architecture too close. But if you use time division multiple access, so this is in one time slot, another in another time slot, so basically they don't coexist in the same time, so they don't interfere with each other by definition. But time division multiple access brings another problem, which is a lower update rate per mobile beacon and some other issues with handover. So if possible to reuse without TDMA, use without TDMA. So if you are using non-inverse architecture, instead of using more station beacons, you can use horns. So you install station beacon and a horn. And in this case, it can be not up to 30 meters, but up to 50 meters or even 100 meters in some cases, if it's, for example, low noise area. If there is a high noise, then you need to reduce the area to keep the signal to noise ratio high enough. But remember that you can install mobile station beacon with the horn and increase it. It works in non-inverse architecture because horn can receive the station beacon, so can receive the ultrasound. But if you use ear or inverse architecture, then horn is useless unless you're using so-called TX horn. We don't have such a product, but we experimented with them, and we can offer it for larger cases. So TX horn, where there's a transducer and the horn, not the microphone and the horn. So again, a bit more about the terminology. So 01, 03, 04, etc. They are service zones. Between them, 05, 05B, and 06, they are handover zones. These are the mobile beacons, N02, N03. They're using N as the same terminology as in dashboard. And so, as I already mentioned, the handover zones. These are the shelves. And the submap is a set of beacons. So in this case, N02 and N03 is a set of two beacons creating a 2D submap with a service zone 01. This is another submap, N11 and 12. This is a submap, and N09 and 10 is another submap. So these are 2D submaps, but these are 1D submaps. So N07 creates a submap 02D with the service zone 02D. So this is a submap, and this is a handover zone between this submap on this service zone and this service zone. Service zone is a property of a submap, and submap is a set of beacons. So what else to mention? I already mentioned about this, and about 1D, 1.5D, etc. So it may look funny, but in reality, it's a very, very real thing. So in this case, you have 1D tracking, but you also need to know which shelf are you looking at, this shelf or this shelf. So this is why we call it 1.5D. So it's 1D plus direction. But the direction is provided mostly by the mobile beacons. So install two mobile beacons and on your robot, for example, or on your forklift. And oh, you can see it here in the placement manual, as we already saw. So install two mobile beacons, and then you know the location and the direction. So where your mobile beacon is facing, to the left shelf or to the right shelf. For example, like in this case. For people, it's more difficult. So this is why there's no solution serving all. So this is why we always ask specific questions. And those questions can be found here. So what are you tracking? What people and what do you want to achieve? Productivity or safety? We need a floor plan for you, photos, videos, etc. So so this is why some solutions like for forklifts is easy, for people it's problematic, more problematic, let's say. It's also doable but more complex. And for drones, typically you don't care about this. You care not to kill the drone by touching with the propellers and crushing the drone. Okay, there was some technical interruption. So with 5.2, drone tracking is still possible. 1.5 is the same. Along the x-axis is used ultrasound. 0.5 is by the mobile beacons. So direction of the drone and Z coordinate for the drone is possible from barometer, for example. So you have a height from the barometer. 2.5D tracking from the forklift is also possible, but instead of barometer, you have a Z tracking against the stationary beacon on the forklift itself. So of course, against the walls, the stationary beacon on their forklift is not stationary, it's moving. But for their mobile beacon on the fork, it's stationary. So you get the coordinate from there. So it's typical, and we use the same approach for cranes tracking, for example. So if you want to see how it works in practice, and handovers between 1D tracking, then 3D tracking in this area, then moving back 1D tracking, and then there will be 2D vertical tracking on the stairs, so you can watch this video. So it's nothing unusual, and it just helps you to optimally use the equipment. So with few beacons, you can achieve the same. So about these special areas we already discussed. Remember, so this is a primary topic of this discussion, but there are some other areas like this one, like these ones, and like these ones, which are available or which are present in many other cases. So we are just describing them in more details here. So remember and enjoy. And remember that since we build a solution from scratch, so you can nearly always find an optimal configuration. If you are not sure, check placement manual. If you are even less sure, then contact us over email, and we are always happy to help. Thank you.